Hi guys, welcome back. In this video, I'm going to show you the law of cosines for what we call a side scenario. Okay, I showed you a side angle sine a minute ago on the last video, but side. Okay, so as we recall, the law of cosines goes a squared equals b squared plus c squared minus 2bc times the cosine of a. Or you could do that same thing with a B here and a B here and AC, and so on and so forth. Okay, but we're going to complete a triangle today. Keep it simple, ABC, right? And that's going to be the main goal. Complete a triangle with a side scenario. Okay, so let's say we got a triangle ABC, right? And let's say A is 22, B is 21. C is 12. Okay, so what you notice here is they give you three sides, right? So if you were to draw that, A, B, C, A would be here, B would be here, C would be here. Okay, now I want you to make a note here. We can't use the law of sines here because to use the law of sines, you'd have to have, you know, you'd have to have an angle and a sine that match up. And the problem is we don't have any angles here, right? So this is a scenario where you have to use the law of cosines, okay? So you're in a unique situation here because you can actually pick whichever angle you want to solve for. That hasn't always been the case with these problems, but here you can solve for whatever you want to, okay? But I'm going to give you a hint. You're going to want to solve for the largest one first because that's going to save you some headaches in the end. I'll show you why here in a second. But if you look at these angles, right, which one is the largest? Okay, well, since that 22 is the largest side, if you go right across, that would be the largest angle. So what I'm going to do is I'm going to use the law of cosines that has the angle A in it, right? So that one goes like this. It was the one I just wrote, a squared equals b squared plus c squared minus 2bc times the cosine of A. And basically, we have all this information here except for this. So what I'm going to do is I'm going to show you how to solve this for angle A, okay? So let's say what we have. We have A is 22, B is 21, C is 12. So I'm going to go in and fill that information. So watch this real quick. Let's see. I'll say 22 squared equals 21 squared plus 12 squared minus 2 times 21 times 12 times the cosine of A. Okay. Now, all we got to do is get this by itself, and we can solve for A. But the algebra on this, a lot of people do mess up on. So let me go ahead and get this going. Okay, so 22 squared, I'm going to simplify some things. That would be 484, right? 21 squared would be 441. 12 squared is 144 minus 2 times 21 times 12. 2 times 21 times 12 is 504. And then we have cosine A, right? Now, please make note what I'm about to tell you, okay? Once I add this right here, 441 and 144, so I got 484 equals, let's see, 441 plus 144 is 585 minus 504 cosine A. So when you look right here, the main mistake people make on this problem is they'll take 585 and subtract 504 right there. And they'll say, okay, that's 81. Don't do that. Because see how this 504 is attached to the cosine of A? Okay. The algebra here is the same every time. That 585 we need to subtract from both sides, right? And when you take 484 minus 585, you get a negative 101 equals negative 504 cosine A, right? Now what you want to do is you want to divide both sides by -5/4. So divide by -5/4, divide by -5/4. So what we get, -101 divided by -5/4, that would be cosine of A equals 101 over 5/4. Okay. Sorry, let me show you that. Okay. So now we say the cosine of A is 101 over 5/4. Here's what we're going to do, okay? We are going to take the inverse cosine of this. So if I want angle A, right here, right, I say inverse cosine of 101 over 5/4. And you can type that straight in your calculator. Inverse cosine 101 over 5/4. And that will equal about 78.44 degrees, okay? 78.44 degrees. Now, here's what I want to tell you about this, okay? The reason we solve for the largest angle first is this. In a triangle, you could have obtuse angles, wouldn't you agree? Okay. But the only one that has the possibility of being obtuse is the largest one, right? So this one, in this scenario, it actually ended up being acute. But the only one that could have been obtuse is this one, right? Because you can't have more than one obtuse angle. So by doing the law of cosines, here's the cool thing about it. You remember how inverse cosine is a rainbow like this, right? If it's obtuse, the cool thing about inverse cosine is it would tell you it was obtuse. So basically, if this ratio had come out to be negative, we would have an obtuse angle. But since it came out to be positive, we had like a 78.44, right? So let's say you had solved for angle B first, okay? B would no doubt be acute. Well, when you go to solve for A, you're probably going to want to use the law of sines now, because now that we have angle A and side A, we can go back to the law of sines. If you were to go back to law of sines and use inverse sine, if this one was obtuse, it wouldn't tell you, because remember how inverse sine is like a not rainbow, and it'll give you an acute angle always. So what I'm trying to tell you is this. If you solve for the largest angle first using the law of cosines in the side scenario, okay? If you solve for the largest angle first, you won't have to go through that scenario, okay? So now that we have that, and law of cosines is admittedly a little harder than law of sines. It's not that bad, but it's a little more work, okay? But here's the good news. Now that we've done that, we can simply go back to the law of sines, because we have angle A and side A, right? So what we could say is we could say sine 78.44 over 22 equals, let's say, say you want B. You say sine of B over 21. And this is going back to the law of sine stuff. So all you have to do is multiply. So you say 21 times this. You say 21 sine 78.44 equals 22 sine B, right? You divide by 22. And basically, you find out what this is. So if I say 21 sine 78.44 divided by 22, this is about 0.935, right, equals sine B. All we have to do is take the inverse sine of that. So if I do inverse sine of that answer, I'm getting 69.26 about. Okay, so I'll go up here, put a 69.26. Okay, now for one angle C, I mean, that's really easy. 78.44, right, plus 69.26. You take that out of 180, and that would just be 32.3 degrees left over. Okay. So there you have it. You have the law of cosines for sine side side. Okay. If I were you and you want to save headache, in a side scenario, always solve for the largest side first. That way you can use the law of cosines to your advantage, because inverse cosine will tell you if it's obtuse or not. Okay. So one more example, we'll call it a day. let's say I did this. I don't know. I'm gonna make up some numbers here. So let's say I did um, 10, 11, and 10, 11. Let me change that. 10, 12, and 1. 10, 12, and 1. Okay, so draw a little triangle A, B, C. You got 10, you got 12, you got 1, right? Okay, so 10, 12, 1. Let's say you want to solve for the largest angle first. Which one of these would be the largest angle? It'd be B, that's right. So watch this. B squared equals A squared plus C squared minus 2AC times the cosine of B. So we put this information in. We got 12 squared equals 10 squared plus 1 squared minus 2 times 10 times 1 times the cosine of B. So let's see, that's 144. That's 100 plus 1. 20 times 1 is 20, right? Cosine B. So let's check this out. 144 equals 101 minus 20 cosine B. Remember here, don't subtract those, right? You want to subtract the 101 over, right? So if you have 144 minus 101, that would be 43 equals negative 20 cosine B. And then you divide both sides by negative 20. And what you get cosine of B equals 43 over negative 20, right? Okay. So all you have to do is do inverse cosine. So do inverse cosine 43 over negative 20. And look at what your calculator says. Okay. Let me see that, but it says error. Okay. Reason being is 43 over 20 would be under negative 1 actually. So you can't have a cosine of that. So this side scenario, this can't happen. Okay. There's no triangle that can be formed with those three sides. Okay. And so just like when we had the side angle for the sine, you could get 0 triangles. This is another one where you want to watch out for 0 triangles side. Okay. But instead of doing all this, let me give you a little hint. Okay. Here's something you can do. Instead of going through all that work, let me show you something. Okay. These three sides can't physically form a triangle. I'll show you why. Okay. If you take any two sides of a triangle and add them up, for them to physically make a triangle, they have to be bigger than the third side. So let me show you this. What's 10 plus 12? It's 22, right? Is 22 bigger than 1? Yes. Okay, let's try this again. What is 12 plus 1? Well, it's 13, right? Is 13 bigger than 10? Yes. Here's the problem. 10 and 1, right? Okay, 10 and 1. 10 plus 1 is 11, which isn't bigger than 12. So what that would mean is like this. If you had a side of 12, right? And you had a 10 and a 1 like this, there'd be no way that could possibly close off, because even if you laid them down flat, it wouldn't be as big as the 12. So you can't physically form a triangle with this. So if you wanted to just check it at the beginning, just say, are these two bigger than this? Yes. Are these bigger than this? Yes. Are these bigger than this? No. You could just say, no triangle formed. Okay. I'll give you an example of one we know that you could check really quick. We all know, like, let's say A is 3, B is 4, C is 5, right? We all know this is a triangle because that's a pretty famous 3, 4, 5 Pythagorean triple, right? But you can see that these two add up to 7, that's bigger than 5. These two add up to 9, that's bigger than 3. These two add up to 8, which is bigger than 4. So this would actually form a triangle. This would not. Okay. So if you ever wanted to double check that at the beginning, it could save you a lot of time. But I just want to tell you that on a side, you can get a no solution, okay? So once again, on a side, you have to use law of cosines, right? And you'd be better off solve for the largest angle first, then go back to law of sines, okay? So hopefully that helps you guys. I will talk to you soon. Remember, quiz is on Friday over law of sines and law of cosines, all right? See you later.